Current connections 2. Low delay mode off. We should be working. Alright, perfect. Goodness, sorry about that, everybody. Let me go inside where it's air conditioned. Welcome back to Paleontologizing, everyone. I'm here in Rapid City, South Dakota, at the South Dakota School of Mines. And we are about to take a tour of the museum. Alright, I'm glad this is finally working. Let's see. Very cool. Well, thank you so much for your patience, everybody. I think we're going to have a great time today. As you can tell, I finally got the replacement modems all set up, and I'm here in the great state of South Dakota at the South Dakota School of Mines, and we're going to visit the Museum of Geology. Very excited. I've never been here before. I've heard very good things. A friend of mine is actually a professor at the museum, Dr. Sarah Keenan. We dug up Yoshi's trach together back in 2011. So I think she works on taphonomy now. So yeah, I don't think we're going to see her today. Hopefully she's off doing field work, having a great time right now. But this is her neck of the woods. And welcome everybody. You can hear me right now, right? Give me a 3 in chat if you can hear me all right. And then we'll go ahead and start checking out the museum. All right, we're getting some 3s. This is good too, and that also gives me an idea of the delay time for this. Not that high, which is good. We're in low resiliency mode right now. So yeah, here we are ascending the stairs here. And check this out. Holy cow. Beautiful elasmosaur skeleton over there. Big old Columbian or maybe Imperial mammoth skull. Some bison skulls. It's going to be really neat. Hey there, how's it going? Doing well, thanks. What's that?
What you working on?
Oh, so I'm doing a live stream right now.
Okay.
I do science outreach full time, so and I'm a paleontologist too. So it's my first time here at the museum, and I'm impressed so far. That elasmosaur is incredible. Yeah.
It's about 70% complete.
Yeah. Oh, so those are
Real bones, partially real bones.
Really?
It was knocked a long time ago.
okay, gotcha. I can see some of the armature under the rear flippers, I guess.
Yeah.
Yeah.
We've been in this building since the 1940s, I believe, is about when that probably would have been
Cool.
done. And we obviously wouldn't do that nowadays. But yeah, the percentages approximately are about 70, 60, 50.
Very cool.
Big guys there.
Neat. Just out of curiosity, you haven't seen Dr. Sarah Keenan around at all, have you?
Not today, no.
Not today? Okay, I used to work with her.
Cool.
Yeah.
You might be able to catch her up in the PR.
Oh, really?
It's up in there.
Gotcha. She's actually in today?
Possibly.
Okay.
If she is there.
I didn't contact her in advance or anything, so I don't want to bother her, but yeah.
But sometimes if you're there, you can see her back and forth between
Cool.
locations and-
I might have to stop by there then. Yeah.
it's
Thanks
just
very much.
behind us.
Cool. Thanks. All right, let's go check out that elasmosaur. Yeah, and it looks like somebody just followed too. Somebody just became our 10,000th follower. Welcome to Paleontologizing. It is great to have you here. Just as little introduction, my name is Danny Anduza. I'm a dinosaur paleontologist, and right now I'm on this great big road trip going all across the United States, visiting different fossil museums, different fossil sites, talking to other fossil scientists. And right now I'm at the South Dakota School of Mines, Museum of Geology, and very impressed so far. This is pretty cool. Yeah. And GG on the 10,000 followers. Thank you, Jenna Strand. Thank you. And by the way, hello to everybody. I know we didn't do our normal hellos like we usually do at the beginning of a broadcast, but welcome Jody Fish, Ornis, Golganek, Claire Burr, Maddie Holmes, Haraz, Ant Streams. How are you doing, Balint and Lita? Hope you're doing really well. Jenna Strand, Golganek. How is everybody? It is so good to have you all here. Shoot, let's why don't we start over here just to kind of get our geological bearings at the Museum of Geology. They have this lovely time scale right here. So let us take a look. The further down you go, the older it is. Further up, the closest to the present day. I like that this is almost kind of to scale. It shows the Cenozoic being pretty small like that, as it should be with comparison to the Cretaceous period. But right here is the Mesozoic, the age of dinosaurs, and up there is the Cenozoic, that's the one we're currently in. We're at the very, very top, the age of mammals. So, speaking of mammals, let's take a look at some of them. Look at these guys. These have got to be pretty early, I would suppose. These are what, Eocene? The big badlands of South Dakota. Very cool. Poleside member Brule Formation. Not familiar with that formation here. I'm guessing this is probably Eocene. There's fossil footprints in that slab right there. Very cool. That's probably some kind of little orodont, creodont, something back there. Let's see. Protocerus. Okay. Very cool. And that little guy right there is an oreodont, like I thought. Very cool. It's very cool, kind of early Cenozoic mammals. Oreodonts used to be super, super common, just all over the place. Now they're completely extinct. They've got no living representatives for that whole group. That's, yeah, very, very cool. And Tarquin says, tiny horses? No, these predate horses. Or at least they're not on the same lineage as horses. These are different critters entirely. Yeah. Let's just read from here. It says, one of the more bizarre animals of the Badlands is the horned mammal Protocerus celare. This skeleton is shown standing on the sandstone slab. So that's Protocerus right up there. So that name might sound kind of familiar. There's some familiar parts to it. Protocerus would mean like first horns. Proto meaning first, cerus meaning horns. Like Triceratops, three-horned face. Protocerus, first horns. Yeah, pretty cool. Yeah, the closest living relatives of these animals are camels. Gotcha. So these critters, I guess, are part of an archaic group that doesn't have any living members. Very interesting. Very interesting. Pretty cool. So these would be from, I'm guessing these are Eocene. No, shoot. Upper Brule Formation. I don't know how old the Brule Formation is, but that little oreodont guy there, that little kind of sausage-shaped little mammal, is apparently from the late Oligocene. So from, yeah, not the very beginning of the age of mammals, but a little while afterward, after mammals have really started developing all kinds of different body shapes and forms, large sizes too. So yeah. Very cool. Let's move on from here. Oh, and by the way, that apparently is what those little guys look like in life. Oreodonts are such cool, weird animals. Like, I don't know how to describe them. I don't know. How would you describe those guys, everybody? Oreodonts. I like the speckles on them in that painting. Pretty cool. Very neat. And TMK says a lot of wind noise. Yeah, that's the air conditioning, actually. If you're hearing kind of a thrumming, humming noise, it's the AC right up there. So unfortunately, there's nothing I can do about that. But luckily, it's nice and cool in here, even though it's very hot outside. Whoever says pig deer, they are kind of like pig deer, I suppose. It's a good, I suppose that's a pretty good descriptor for an oreodont. So yeah. And let's take a look at some of those. We've got some early camelids, looks like. Camelliformes. Early camels. Very neat. And this is, I wonder if there's a name for this particular kind of, like, display style. This kind of like bas relief thing where this is very common in like older museums, where you mount a skeleton like this, but it's kind of up against the wall, like you see right there. The classic one was always Eohippus. I've seen so many different reconstructions of that same fossil mount of that early horse, Eohippus. Pushed up against the wall like that. Very cool. Yeah, looks like they're standing in an alcove. Yeah, kind of. Look at that big old turtle right there. Very cool. And that's probably another Oreodont. Let's check. Here we go, yeah. Oreodonts. And I recognize that artist. You see a lot of their stuff on Wikipedia. Nobu Tamura has done a lot of reconstructions of extinct critters for Wikipedia. Yeah, it is kind of a pig deer. That's a good way to put it. What's a fine descriptor there, Claire? And yeah, so there we've got Gopherus laticuneus. I guess that's just like a giant gopher tortoise right there, or something similar. Got the Oreodont there in the back, Maricoidodon. And then number 3, we've got some more little Oreodonts stuck in there. Very cool. Really was the age of the Oreodonts. And can anybody guess what that critter is right there? Any guesses what this beastie is right here? Wish I could play the Jeopardy music for you. Yeah, and Ornis, you are exactly right. That's an Entelodont right there. They're sometimes called hell pigs. I don't think they're actually within the same exact family as pigs, but they're close relatives. And they, yeah, I think it's still kind of up in the air what their diet was like. Again, I'm not a mammal paleontologist. I don't know enough about those critters. But I remember talking with some mammal people, I don't know, probably more than a decade ago. Like, what did entelodonts eat? Are they carnivorous, herbivorous, omnivorous? The answer I got was like, well, they probably ate a lot of grass, but I don't know, maybe they ate whatever they wanted. They don't seem to be like obligate carnivores. I don't know. Somebody should do some, well, somebody's probably already done some isotopic studies on these critters, and I just don't know about it yet. But yeah, entelodonts. Very cool critter. Look at those teeth in there. Those big kind of cheek flanges. On a ceratopsian dinosaur, those would be the jugals coming down, those big like cheek horns, cheek spikes. I wonder if it's the same bone on this critter. I bet you it is. I bet you those are flared jugals. Very cool. We've got a little turtle down there too. This is a beautiful display. I like this a lot. And then we've got some kind of felid type guys there. Are those, yeah, saber-tooth cats with cats in quotation marks? Yeah, Hoplophonius. I've heard of those guys. These animals are referred to as false cats because they are of the family Nimravidae. So these are nimravids. They are not cats at all. They are carnivorous mammals, so they're from the same broad group that includes cats and dogs and lions and tigers and bears. Oh my. But they're not true cats. I think these guys go completely extinct, and then that niche is later taken over by cats. And it looks like we might get to learn a little bit more about that at that display over there. But for right now, let's continue with this. Yeah, giant pigs. Quotation marks. Yeah, those critters are not really cats. We'll talk about that in a second, Fedora. Yeah, and Helpnuker, hey, welcome back. And Garazieris, how are you doing? Did you join us from Al Hazred's stream again? Welcome. Oh, holy cow, hang on a second. Did we get a raid? Laura Floresciencia, hey. Bienvenidos a Paleontologizing. Me llamo Danny Anduza, soy un paleontólogo y estoy en Rapid City, South Dakota, ahorita. Bienvenidos, claro. It's great to have you here. Yeah. And Ragandar, holy cow, thank you for all those gift subs. Really appreciate that. Holy moly. That is wonderful. Oh, Skuliki, how are you doing, my friend? Welcome, welcome, Skuliki. Was that raid from you? I appreciate that very much, Skuliki. I hope you're having a great day. It's great to see you. Yeah. Welcome. Yeah, for anybody who's new, I'm Danny Anduza. I'm a dinosaur paleontologist on this great big road trip right now. And I'm streaming to you live from the School of Mines Museum of Geology here in Rapid City, South Dakota. So they've got some beautiful displays, as you can see here. Check that out. Very, very cool. Now the gal at the front desk was telling me that this museum, I think, was built in the 1940s. So, yeah, or at least it's been here in this building since the 1940s. And we're going to see some displays that might show their age a little bit, but I don't know. They've managed to really keep things looking nice and beautiful here. Kind of refinishing some of these in a way that doesn't feel stark or
This is Laura Dern,
jarring. It just all kind of fits. They've done a beautiful job with this. And holy cow, who can tell me what this critter is? Hopefully the camera didn't already pick up the, hopefully you couldn't see the label there. This might be an easier question. But I'd like it to be. But what is this critter? Embolotherium or something? That is a good guess, Tarquin. I think Embolotherium is related to rhinoceroses. This is a different kind of critter entirely. This is like nowhere close to rhinos, as far as I can tell. I don't think this is even an ungulate. Well, I could be wrong about that. Yeah. Oh, and Galara Dragon, thank you for the resub. I did miss that, but thanks for shouting it out anyway. Thank you for your ongoing support, Galara Dragon. I really appreciate it. Yeah, this critter back here, it's a friend, says not the brain. Yeah, I would say so. This is a Brontothere. Yeah, check it out, Brontothere skeleton. From Keister Ranch near Imlay, South Dakota, collected in 1949, and donated by Mr. Henry Keister. Very cool. So this was found on private land, apparently, and then donated by a benevolent landowner. That's pretty wonderful. I don't have enough of that kind of thing nowadays, so it's worth celebrating. And check that out. Very cool. Look at that big barrel-shaped rib cage. Look at those long neural spines up there above the ribs. Very cool. Probably had big old tendons attached from there down to the end of the neck to hold up that big heavy head. Very cool. So yeah, somebody look up real quick. Somebody look up for me real quick whether Brontotheres are actually related to, or whether they're ungulates at all. They might be like an archaic group that didn't leave any descendants and came from someplace weird. They might not even be part of Ungulata at all. Somebody look up if they're ungulates. Yeah, very cool. So Brontotheres are extinct relatives of horses, tapirs, and rhinoceroses. Oh, I guess they are ungulates. Very cool. The remains are fairly common in the lower rock layer of the Big Badlands, although good specimens are rare. The skeleton of Brontops, that is the name of this particular critter. That's the genus. And the name Brontops might sound kind of familiar. You know Triceratops and you know Brontosaurus. So you might be able to guess what that name means. Brontops means Thunderface. What a cool name. Brontops. Pretty neat. Speaking of Thunderface, take a look at that skull. Really cool. And there's a reconstruction of what the animal might have looked like in life. It's a famous piece of art from Charles R. Knight, famed paleo artist. And look at how far forward the eyes are on that skull. That's nuts. Super weird. Super cool. I mean, check that out. Just amazing. And wait, holy cow, Cyan Streams. A 6-month gift sub to Maddie Holmes? Thank you, Bullet. I really, really appreciate that. I really do. Holy cow. That is wonderful. Somebody's excited about the brown deer heron. Isn't that cool, Bullet? Holy moly. Really awesome. It seems to have much longer limbs than a rhinoceros. I bet you these guys were a bit more nimble, maybe. Makes me wonder how fast they could run, you know?
Thank you very much for the 100 bits.
Yeah, what a cool critter. Yeah, very cool. And Beth 14 fan, thank you so much for those bits. Really appreciate that. Yeah, that's lovely. Very, very cool. Well, from the Brontotherium, let's move on to this display. We were just talking about cats a little while ago, so let's do this. What a cool, well-designed display here. So these are some skulls of cats. So there is a domestic cat skull. Do we have anybody here in chat who has a kitty at home? Because your cat's skull looks like that. Yeah, eyes very close to the front of the head. Big ol' eye sockets.
Appreciation and understanding of fossil science.
And Amberseen, holy cow, thank you for the 1,000 bits. Really appreciate that.
With sincere appreciation and gratitude.
We do have some people in the chat who've got cats. Jody Fish's got 2. Hornus has a cat. Very cool. So this is a clouded leopard skull. That's a cast of one. That house cat, that's a genuine, that's the original skull right there. This is a cast, that's why it's so clean and white. Clouded leopard. Clouded leopards, I think, have the longest fangs, the longest canine teeth of any modern cat. Clouded leopards, but they pale in comparison to Smilodon. I'm sure everyone here is very familiar with Smilodon, whose image appears back there too. Check out those canines. I've got a Smilodon 3D print, Smilodon skull back in my office, so I'm well familiar with it. But that is an original specimen right there. This is not a cast. That is genuine Smilodon skull. You can tell by the imperfections. It's missing some teeth there. Just like the texture, you can see places where it's been reconstructed, touched up a little bit. There's places where it's been glued. Very cool. And this is from Rancho La Brea. So this is from the La Brea tar pits. The world's largest accumulation of Smilodon elements is from what is today downtown LA, downtown Los Angeles. And many specimens have been kind of scattered to the four winds. You can find them all over the world, and we have one right here in Rapid City, South Dakota. Pretty cool. Original Smilodon skull. Very neat. Yeah. Yeah. And pull up the ukulele right now. I can't do that, Anima Confused. Did we get to a level 5 hype train? Holy cow. Thank you, everybody. Can somebody report? Let me know, because I can't really see here. Can somebody tell me, did we get to a level 5 hype train? Support is incredible, everybody. Thank you so much. Alright, let's take a look here. There we go. So these are not cats at all. These three critters are what we call nimravids. So Nimravidae. So they are outside of Felidae. They are not true cats. They seem to have narrower teeth too. The teeth are kind of, those canines are kind of more blade-like. As you can see right there. look a little bit more delicate, maybe, than those canines of, like, say, saber-toothed cats,
and
like over there.
Thank you very
The whole
much
animal
to the
itself may have been
100s.
a bit more, a bit more gracile. Let's read this. Big Badlands, Big Bites. Convergent evolution. We've talked about convergent evolution so many times on this channel. I hope people aren't tired of hearing about it, but it's just so fascinating. So at first glance, these saber-toothed animals may look very similar. However, while the individuals on the left, these guys over here, belong to the family Felidae, which includes modern cats, the individuals on the right belong to an entirely separate family called Nimravidae. What makes these two families of animals look so similar? The answer is convergent evolution. Convergent evolution. I want everybody to remember that term. If it's not already stuck in your head, I want it to be by the end of this summer. I don't ever want you to forget that convergent evolution is such a cool phenomenon. It's very important to be able to recognize the difference between that and homology, when creatures have similar structures because they're related to each other, you know? Anyway, convergent evolution occurs when different species evolve some of the same traits, even though their last common ancestor did not have those traits. That's a beautiful, beautiful definition there. While this may sound complicated, you've probably seen convergent evolution with your own eyes. Birds and bats have both developed wings that allow them to fly. However, birds evolved from dinosaurs while bats evolved from mammals. So since both animals developed wings, even though they evolved from different groups, that is an example of convergent evolution. That might actually be the best, most concise definition I've ever heard for convergent evolution. And the clearest. I like that a lot. The different species evolved some of the same traits, even though their last common ancestor did not have those traits. Cool. Yeah. And eyes, too. Eyes are a great example of convergent evolution. Jody Fish, yeah, lots of different groups have evolved eyes, despite evolving from ancestors that did not have eyes. You know, their last common ancestor didn't have eyes. So, picture like this. You've got a split where both of these two lineages develop eyes, but the one here in the middle, the ancestor for both of them did not have that. Does that make sense? So independently evolving the same kinds of traits, that's convergent evolution. Yeah. So members of both Felidae and Nimravidae convergently evolved saber teeth and cat-like bodies, even though their last common ancestor did not have those traits. However, there are some traits that help distinguish these two families. The most visible difference is in their feet. So yeah, our Smilodon, you can see in that reconstruction right there, you know, it's got cat feet. These guys look a bit different, especially in the back. Look at that. Almost reminds me of like an opossum or something. Those hind limbs there. Yeah, members of Felidae walk on their toes, which is called a digitigrade stance, like you see there, like your cat at home does. Whereas members of Nimravidae walk on their full foot, just like you, which is called a plantigrade stance. So see, the ankle is like almost down there on the ground. You see that? As opposed to the cat over there where it's kind of held up. Pretty cool. Does that make sense? I hope it does. Yeah, and Queen Orwinia, yeah. Ichthyosaurs, dolphins, and fish. That's a great example of convergent evolution. Yeah. Pretty cool. And yeah, Claire, I think bears are the same way, where I think they are also plantigrade. Kind of like that. Or at least they're closer to that than cats are. So yeah, we were talking about entelodonts earlier, like with that critter over there, the hell pig. Let's take a look, an up close look at some of their skulls. Holy cow, is that cool. And these are the original specimens right here. That's not a replica, that's not a cast. That is the original. Very cool. So members of Entelodontidae, such as Archaeotherium. These three Archaeotherium, I guess these are all the same taxon. They're often nicknamed big pigs, even though they are not true pigs like those we see today. These large omnivores, and again, they probably were omnivores. It's easier to say that than to say, well, we don't really know what their diet was. And maybe we do know what their diet was. I don't know. I don't work on mammals. I'm behind the times there. But anyway, These large omnivores first evolved around 38 million years ago and became extinct 19 million years ago. Can you find the exhibit in the museum named after these big pigs? I think we just saw it, but yeah. So check that out. Archaeotherium mortoni. Very cool. And interesting, this one doesn't have a species name, it just says Archaeotherium, just the genus, no species. I wonder if the taxonomy for these guys is a mess, like it is for so many critters. But let's just assume for a second that these are all the same genus and species. These are all the same animal, the same population. Look how much they change as they grow and mature, if that's the case. Like look at the shape of the those jugal flanges, kind of cheek spike things coming out of the side. So notice how right here, it kind of comes up and then like that. And these guys, it doesn't over there. It's just kind of nice and smooth. And that could be a difference between species or through time, or it could be through ontogeny. That's why it's so important to, I don't know, to sort all those variables out when you're trying to do paleobiology. So yeah. And the cheekbones on those are huge. They are Triceratops, aren't they? Kind of reminds me of a ceratopsian with the big cheek spikes. I mean, check that out. That is pretty impressive. And just look at those teeth. See, these are not super sharp teeth. They've got some serious wear on them like that. Like, look at that kind of tusk there in the front. How the end is just all worn down. Huh. I'm guessing these guys are probably mostly eating vegetation, which can be really tough on your teeth, all that silica, especially if you're eating grass. Wear down your teeth right quick. Yeah. Pretty cool. And look at that weird little flange coming off of the lower jaw right here. See that right there? Really strange. I don't know what that's about. Just crazy. And mammal skulls are so weird. I'm so not used to them, you know, despite being the owner of one. I don't know. It's a weird thing. And TMK, these are not cast. That's the original fossil right there. Check out that specimen number, 40140. Yeah, and then look at the texture. You would have to spend a long time painting a cast to give it that kind of yeah, it wouldn't even be worth trying. And you can tell there are a few parts of this that are filled in. So look at the top of the sagittal crest up there. You can see there's some plaster that's been used to kind of fill in some of the gaps. Just like all along the top of that little crest up there, sagittal crest. See how it's kind of too smooth? So that is plaster that's been used to fill in. But most of this is original. I can tell a few places where plaster's been used to fill in cracks and missing bits, but for the most part. And there's the original matrix in there too. If you look inside the eye socket, you see those kind of scrape marks in there? Scrape marks around the matrix. Pretty neat. So there's some of the original rock still in the skull from when this thing was dug up. Pretty neat. Pretty neat. And Maskling, thank you so much for the bits. Really appreciate that. Yeah. Very cool. And it's decorative, could be Golganek. I mean, shoot, it's my standard answer when we talk about dinosaur morphology. Weird, features that don't seem to make much sense for anything else. Display is kind of the standard answer. So yeah, before we take a look at this beautiful hadrosaur, that trike skull or the rex or the Zyphactinus, we were talking about that a few weeks ago. Before we get to any of that, or these guys, let's kind of eat our vegetables first and go through the mammals. Because we've got some very cool ones right here. Big old Gomphotherium skull. Take a look at that. Pretty extraordinary. Look at this. Let me crouch down for scale here. But Gomphotheres are relatives of modern-day elephants. So they're proboscideans. They're, trunked mammals. The only proboscideans we still have around today, we've only got 2 species. Shoot. Loxodonta africana, I think, and whatever the binomial is for the Asian elephant, I forget. But yeah. Pretty cool. The size of that skull and those tusks. Pretty extraordinary. And that lower jaw. Very cool. So these guys are right here in South Dakota, up until I think just a few million years ago. I'm not sure when exactly Gomphotheres kicked the bucket, but let's read the sign here. Even I don't know enough about these critters. Gomphotherium, a long-jawed elephant-like animal, was common in western North America approximately 10 million years ago. There you go. This individual is remarkable for the very complete skull and jaws. The remainder of the skeleton includes 2 shoulder blades, 1 upper hind leg bone, parts of the pelvis, some vertebrae, and most of the ribs. So all those postcrania you can see right here. Check that out. Very cool. Man, look at that. Look at that femur. Kind of shorter than I would expect. You guys didn't have very long legs compared to the size of their head, I suppose. Very cool. Alright, let's finish that sign. Get distracted. This specimen was found near Hidden Timber, South Dakota on the Rosebud Indian Reservation. In addition to the Gomphothere skeleton, remains of carnivore bones and fossil grass seeds were recovered. The Gomphothere was a relatively old individual because the teeth in each jaw are 3rd molars and are worn considerably. There's a strong possibility that it was a female because of the lack of tusks in the lower jaw. Gomphotheres were browsing animals, which indicates a richer vegetation in South Dakota when they were alive. That's interesting, because the teeth there, they are very worn looking. But they're not quite as, the cusps, the crowns on them are not as high as I would expect from a browsing animal like a mastodon, you know? Or maybe these are just incredibly well worn. But yeah, take a look at those teeth. Very cool. And 3rd molar wisdom tooth. Yeah, basically Jodyfish. If I recall correctly, proboscideans like this, they actually have, I think they have multiple sets of molars that kind of march forward as the animal lives out its life and the teeth in the front get worn down. But they only have a few sets of them. It's less than 6, I think. And there are modern day elephants where, they can have a very successful life and grow to be very old and stay healthy the whole time, and then eventually their teeth wear out and they don't have any replacement ones left, and even if everything else is going well for them, they won't be able to eat and they starve. This is one of the trade-offs that mammals made, when we switched from having constantly replacing teeth like most tetrapods do. Mammals have just got a few sets for their whole lives. We only have 2, our baby teeth and our adult teeth, and then we're done. Yeah, I don't know. That was a trade-off we made very early as mammals, and we've got to deal with the consequences to this day. So yeah. And yeah, there you go, Matty Holmes. Yep. And a few rare people are lucky enough to 3 sets. Is that true, Matty Holmes? I've never heard of that before. Huh. And Huygens says mammals got the short end of the stick when it came to teeth. Well, kind of. I mean, because when we have, after you lose your baby teeth and get your adult teeth, you've got a set of teeth that's all there all at once. You're going to have a very precise bite if everything works out well. And creatures that are just constantly replacing their teeth all the time don't have that, So as mammals, we've kind of traded, quantity for quality, I guess. Yeah. And anyway, yeah. Luckily we can make new ones. There you go, Trek Nerd. Yep. Trek Nerd, always the futurist. always thinking, oh, how can we solve these problems with technology? Dentures and stuff like that is one way to solve that problem, I suppose. All right, now before we get on to our hadrosaur or our mosasaur or elasmosaur over there, let's check out some more of these various mammal skulls. Very cool. We've got some Oligocene mammals. There's the skull of Protocerus, like we saw at the beginning of the stream over there. Here is this critter again, but there is a genuine skull. Beautiful. Look at that. Very, very cool. So you can see those teeth in the front. This is an herbivorous animal, a plant eater. So those teeth in the front, maybe they were used for defense or for display, but not used for killing prey, it seems. I was going to say not used for tearing flesh, but maybe it was in defense. But just, this animal is not a predator. It's not built that way. This, however, is a false saber cat. Another one of these nimravids like we were talking about. Check out those beautiful canine teeth. The teeth in the back, too. Very cool. So, lower jaw, and this, you're looking at the skull, but you're looking at a ventral view, so that's the roof of its mouth right there. And there's some of the teeth. Here's the front of the skull, there's the back, and then there's those saber fangs that would slot in right there at the front. Pretty cool. Pretty cool. And it looks like we got a raid. Let's see. Alpha Matt, holy cow, thank you for the raid, I appreciate it, and welcome back to Paleontologizing. Hope you had a great stream. Welcome, everybody. Yeah. And hello to you, Ryle Peep. Yeah. No pasa nada. Alpha Matt, thank you for being here. Yeah. Alright. Oh, and this is really neat. I didn't even realize this. So, talking about these critters, Protocerus, we've got a male, and we've got a female. Female skull's a little bit bigger. But yeah, so this is what we call sexual dimorphism. So in a species of animal, when you've got males and females and they look different, that's what we call it. And so often it's the male who's much more ornate. He's got those really cool horns on his snout, up there on his top of his head behind his eyes. The female does not have those. She doesn't bother with that kind of thing. Pretty cool. Female and male. Pretty neat. It's really interesting because that's not something that we see in dinosaurs. As far as we can tell, we've never been able to actually identify sexual dimorphism in any dinosaurs. The males and the females looking skeletally different. This doesn't really seem to happen yet. Maybe we're missing something, but I don't know. In mammals, it's just plain as day. We've got it all over the place, like with these guys. Oh, we've got an early dog here. Look at that. Beautiful preservation there. And these, of course, are the actual fossils. So Hesperocyon, that name means western dog. I'm just deciphering this as we go. I don't really know anything about these particular critters, but I recognize the roots of those words. Yeah. Very cool. I mean, look at how big that is. It's like Chihuahua sized. Beautiful. I wonder if that's an adult specimen there. Look at that beautiful skull. Just exquisite. Yeah. So it's interesting. It says dogs first evolved in North America with a Hesperocyon, whose name means western dog. Yeah, I told you. It was only the size of a weasel. Its later relatives, like Epicyon, would become larger than modern wolves. Very cool. So I wasn't aware of that. The dog family, canids, first evolved in North America. Shoot, there's a bunch of different groups that first evolved here. I guess, dogs, camels first evolved in North America. Primates, it seems, may have first evolved in North America. A bunch of critters. I wonder, though, how much of that is actual, how much is actually that those groups did indeed originate here, and how much of it is just the the rocks here are best studied, so we find the earliest examples here in North America. I don't know. But yeah. And then we've got camelidae, camels, like I was talking about. Yeah, although they're not found in North America today, they first evolved here in North America. Yeah. And Matty Holmes, I think primates first evolved in North America. I think the oldest primate ancestors we have, like Purgatorius, are from here in North America. Somebody can look up Purgatorius and tell me if I'm right or wrong. It's spelled just like it sounds. Purgatorius. Yeah. Very cool. These lovely early camels. And notice how these are a lot smaller than the camels that we have today. This is actually a pretty nice representation of what we call Cope's rule. This idea that the longer that a lineage is around, the larger its constituent members tend to get. So, like, usually the earliest member of a group is going to be one of the smallest. All other things being equal, the longer your lineage is around, like, the larger members of that lineage get, you know? Like, horses today are the biggest they've ever been. I was going to say cats, too, but not quite. The American lion, I think, was a little bit larger than like, say, an Amur tiger or something. But anyway, all other things being equal, the longer you're around as a lineage, you know, the bigger you get. And you can see that here with these tiny early camels. Very cool. Yeah. Yeah, very cool. Got a hippo-like animal. I don't even know it. Apinacodon. So out of my element here with these mammals. This is not what I work on. But they're very cool. And then we've got a three-toed horse right here. There's its skull. Mesohippus. That name means middle horse. See, it's starting to get bigger. Some of the very earliest horses had little tiny skulls like that. And this guy is starting to, I don't know, approach modern horse size. There's another skull from Mesohippus right there. Different species though, Mesohippus bairdi and Mesohippus pallidus. Very cool. If I had to wager a guess, I'd say this guy is from a little earlier. Oh wait, no. Apparently they're both from the Brule Formation, Legacy. Huh. Very cool. Alright. And harasses, does that mean that extinction is more likely than decreasing the size? It's complicated, Haraz. Like, I could talk for hours about Cope's rule and what it means, and yeah. Shoot, I remember we had a long discussion about it at DLS, the Dead Lizard Society, back at Montana State when I was there. Yeah, I don't know. It's like you get bigger and bigger generally, and then you go extinct. But there are some times too when critters get smaller. That's kind of rare, you know. Anyway, I guess that's why it's Cope's rule and not Cope's law or something like that, you know. There's lots of exceptions to it. So yeah. So let's take a look at these. Oh, beautiful. We've got some lovely fossil vegetation here. Fossil leaves. These are from the Eocene, so they're going to be about 50 million years old. Look at how well preserved that is. That is stellar. You can see the veins in the leaf right there. I bet you if you were to take it under a microscope, you could see some of that super fine detail, like the pores on the leaf, like you would see in a modern leaf. Very cool. I'm going to adjust this camera here so I can pull it a little bit closer. to some of these specimens. There we go. Go like that. Take a look. Just extraordinary. And there, does anybody recognize that name? Sequoia? Like a modern giant sequoia? It's the same genus, but 50 million years old in Colorado. It's really amazing. It's beautiful. These are, of course, some of the most beautiful specimens, which is why they're on display right here. Yeah. Really stellar. And redwood, yeah, Claire, the modern coast redwood is Sequoia sempervirens, I think. That's the genus and species name. So this is that same kind of tree, that same genus, the same closely related group of species, but from 50 million years ago. Pretty extraordinary. From Florissant in Colorado. And then we've got some fishes here. Who here likes fish? Because you're going to see some beautiful ones. Here's a fossil perch from Green River in Wyoming. Just extraordinary preservation. You probably heard that before, Green River Formation. It's, yeah, some of the most well-preserved Cenozoic small vertebrates are from the Green River Formation. And invertebrates too, I suppose. Some other fishes. Very cool. And I could spend all day here. There's some fossil algae right there, like an algal mat. Very neat, also from the Green River Formation. It's interesting, that's preserved in 3D. Most of these things are squashed flat. It's cool to have something in 3D like that. Yeah. There you go. I think I'm on the same page as you, Jody Fish, yeah. Yeah. And check out this alligator skull right here. Very similar to a modern alligator from the Chadron Formation. I don't know how old that is, but pretty cool. And look at that distinctive texture over the surface of the skull. I found croc skull bones in the Hell Creek and in the Judith, and you can instantly tell it's a croc just by that very distinctive crocodilian texture. Their scutes, the like armor plates on their bodies, have that same kind of texture too. Very, very cool. Yeah. And then fossil eggs from duck-like birds. When and where are these from? That's pretty cool. Pretty neat. Pretty neat. Yeah. 37 to 34 million years ago. Cool, masculine. Cool. No, I guess it's kind of a testament to what a good gig that alligators and crocodiles have got going, that they haven't changed all that much in tens of millions of years, at least to our eyes, you know? They've got a pretty stable kind of, they've got job security, I guess. If, externally they look superficially similar to how they did 30 plus million years ago. Pretty cool. Of course, there's always going to be minor changes, like their genes are always going to be changing a little bit. You've got genetic drift happening, and they're adapting bit by bit to changing conditions. But overall, it's not like a night and day difference, you know. Oh, cool. Check this out. Got some fossil eggs right here. Found by Dr. and Mrs. Harold J. Cook of Agate, Nebraska, in the Chadron Formation, Oligocene of Dawes County, Nebraska. The eggs, when discovered, were grouped in an area about 4 square feet. It is reasonable to assume that they were from a single nest. The genus of the bird that laid these eggs cannot be known. I wouldn't say cannot be known, just isn't known yet. But is believed to have belonged to a family with duck-like characteristics. That's a funny turn of phrase. Family with duck-like characteristics. Anybody in chat have duck-like characteristics? Yeah. And Dinosaur Dave? Yeah. Wait, there was a running crocodile only a few thousand years ago? I thought those died out in like the Oligocene or something like that. Sabisasukid or something like that. Maybe I'm thinking of something else. But yeah. Very cool. It's a nice fossil bird right there. Might not look like all that much, but that is a very well preserved specimen. Holy cow. Yeah. And again, all of these are originals. Like, these are not reproductions, these are not casts. These are the original fossils here. Just beautiful. Yeah. And it does seem like we have some chatters with duck-like characteristics. Thank you, Enema Confuser, for the 5 months of support. Really appreciate that. Holy cow. And we've got a stromatolite here. Very cool. It's just been cleaved and polished so that you can see that internal structure. It's like cool algae. And one of these beautiful Green River fish. And Ecmatemes, Wyomingensis. Ecmatemes, very cool turtle. Got some fossil wood. I like how it's not everything is a big vertebrate around here. There's all kinds of cool critters here at this museum. They've really packed a lot of stuff into here. I'm impressed. This is pretty cool. Let's go ahead and go around the rest of this case, and then we'll get to some of our big vertebrate critters that I'm just itching to get to, you know? Yeah, I like turtles too, Cargo Cold. Safarix, Xander Jiggles. There you go, who thought though, and Procyon. And Dinosaur Dave. Oh, you've got an Australian terrestrial crocodilian, is that right? I'm not familiar with that, Dinosaur Dave. That sounds really neat. Yeah. And Tarquin says it feels like the whole ecosystem rather than just the flashy stuff. I like that. I mean, there's multiple ecosystems represented here. But yeah. Well, I'm sorry you're sore, Claire. Shoot, does not sound fun. And hello to you, Mudman. How you doing? Oh, nice. We've got a cool little display around here of the process of fossilization. Oh, that's really neat. What is a fossil? Physical evidence of prehistoric life preserved in the ground, such as skeletons or tracks. Oh, so we've got so many different examples here. This is really neat. We've got some tracks from a trilobite. Holy cow. Trilobite trackways right here. Those little scoot marks. Almost look like train tracks. Trilobites scooting along the bottom of an ancient sea. We've got a fossil leaf, fossil teeth, and everybody's favorite, coprolites. It's fossilized poop. Very cool. They were made by a marine animal 75 million years ago. They were found in Fall River County, South Dakota. Very cool. And burrows. There's some fossil burrows right there. If the burrow of a living creature gets filled in with other sediment, then it can actually become a fossil. And that's what that is. Pretty neat. And those are made by shrimp 70 million years ago, so they're from the late Cretaceous. They're found in northern South Dakota near Mobridge. Yeah, what a neat display. This is really cool. Decay, burial, transformation. I get this question a lot. Like, how do fossils actually form once a critter gets buried? Yeah. Oh, and here we go. Very cool. I guess we've got 6 different ways that are laid out right here for becoming a fossil. Or no, 5, I guess. No, 6. Original material. So in amber, you can actually have the original organic material get preserved. And I suppose that is a form of fossilization. Yeah. So there's flies, a beetle, and an ant. And those bits of amber there. So yeah, in amber you can actually get the original material preserved. And then we have replacement right here. That occurs when minerals in the skeletons are replaced by new minerals. These 450 million year old shells called brachiopods have been replaced with an iron mineral called pyrite. These are found in Silica, Ohio. And you can see the kind of shininess. See that right there of the iron pyrite? Very cool. Must be really important to to keep this thing low humidity in order to keep them from decaying. If they're infused with pyrite. Yeah. You can have recrystallization. Occurs when the minerals in the skeleton change their crystal structure into a more stable form. The shell is from baculite, a relative of modern-day squid and octopus. The calcite that was originally present in the shell has been recrystallized. If you look closely, you can see the crystals. And take a look at that. I can see. Can you see, chat? Very cool. Very cool. And, yeah, carbonization. Rocks that have very fine layers, kind of like in Liaoning province in China with those feathered dinosaurs. Or at Solnhofen, or the Santana Formation, or the Green River Formation. You can get carbonization occurring. And rocks that have very fine layers, the remains of plants or animals can be flattened and transformed into a thin film of carbon that preserves details such as feathers, scales, and fur. This 50 million year old fish from Wyoming was preserved in fine sediment at the bottom of a lake. And the other fishes that we saw over here are preserved in the very same way. So you actually have soft tissue that is preserved alongside the bone, which is pretty neat. Sometimes you can even see like what the fish ate last, what its last meal was, stuff like that. Cool stuff. And then we've got molding and casting, and permineralization are our last ones. Molding and casting, I think, is pretty obvious. Sometimes if the original thing just, dissolves away, if it rots, if it's decomposed, then the hollow that it leaves in the rock can be filled in by other minerals, creating a natural cast. Then you have permineralization. That's when pores in the skeleton or wood are filled by minerals. And, yeah, very cool. Very, very cool. So I think permineralization is, that's probably the most common means by which dinosaur fossils are preserved. But yeah. Oh, and very cool, Lenina. You're going to do a stream from your local zoo in August. Want to show everyone art? That is going to be amazing, Lenina. Shoot, let me know when that's going to be. I can't wait to see it. Yeah. Super cool. Speaking of Komodo dragons, or varanid lizards at least. Got this right here, this amazing mosasaur. Here is an actual skull. One of these guys, Prognathodon overtoni, from the Pierre Shale, Mule Creek, South Dakota. So this is from the late Cretaceous period. I know a little bit more about these because they lived alongside the dinosaurs. From the late Cretaceous period, and this is from like just before Hell Creek times. So just before critters like Triceratops and Tyrannosaurus were walking around on land, these critters were living there in the sea. And I say that because it's from the Pierre Shale, which is, it underlies, later land stuff like the Hell Creek. So yeah. That sea that we're always talking about all the time, the WIS, the Western Interior Seaway, that once covered the interior of North America. Critters like this were swimming around in it. Check out those teeth. Just beautiful. Big little eye socket there. Yeah, you would not want to be in the water with one of these guys. There's the lower jaw. You can see those gorgeous teeth there. And as you can tell, the back of this has been reconstructed. That's why it looks all smooth and clean. It's just to show you like the full scale of the lower jaw. And then we get to the real bone right here. Very, very cool. Yeah, pretty neat. So speaking of Cretaceous stuff, let's take a look at some of the other marine life from the Cretaceous, including some of these ammonites. Take a look. Beautiful crabs right there. Very cool. Oh my goodness, look at that Placentaceras. That is incredible. Look at the patterning on that shell. So I think that's not like for appearance sake. Like the shell would have been different colors in life. So it's not like you're looking at the like true to life colors of the animal. I think those are just the suture patterns. So each of these shells, these coiled shells here, they've got like different segments that fit together. And I think that super floral, super intricate pattern right there might actually be the pattern of sutures in between those different segments. Just extraordinary. Some of these still have the original like mother of pearl kind of sheen to them. Like that one right up there. The Hoploscophites. Some of them are more earth-colored. A lot of that just has to do with the preservation. So, you know, the conditions under which these things became fossils will change what they end up looking like when they're fully fossilized. So sometimes you get that beautiful mother of pearl that's retained, and sometimes some of that original material gets replaced by other minerals in the ground, and you end up with more kind of, you know, earthy colored ammonites. And sometimes you've got kind of both in the same specimen, like with some of these. Very cool. Very, very cool. Just beautiful. Yeah. Yeah, let me read this little placard here. It says, during the time of the Cretaceous period, it's the last period in the age of the dinosaurs, invertebrates underwent some of their greatest diversification, the greatest of which was that of ammonites, with the development of complex shapes and structures. One of the most awe-inspiring characteristics of the ammonites are their suture patterns, which can be observed clearly in the Placentaceras specimens. Holy cow, I was right. Those are the suture patterns there. So look at that. Just look at those beautiful, beautiful kind of like patterns on the shell. Those are structural. So those are the actual joints between different segments of the shell. Those are the sutures. Just extraordinary. Incredible preservation. Just absolutely beautiful. And over here, this is interesting. Fossilized versus petrified wood. If you like pretty stuff, then I think you'll enjoy this. Interesting. Fossilized versus petrified wood. These two types of fossils are often mistakenly considered to be interchangeable. Almost everyone has heard of petrified wood forest in some part of the country. In fact, there used to be a petrified forest just outside of Rapid City. It contained pieces that looked like the wood on the outside, but the inside was a colorful array of crystal formations. These colorful patterns are formed by a fossilization process called mineralization, or permineralization, like we just saw in the last display. So as the wood decays, the minerals crystallize and form beautiful patterns, but do not keep any of the interior structures of the plant. So fossilized wood is preserved by minerals replacing the wood, similar to what happens with petrified wood, but unlike petrified wood, the interior structures of wood are preserved. Interesting. Okay. So in this case, you can still see those original rings in there. So this would be fossil wood and not petrified wood. And something like this, those minerals have crystallized in such a way that everything's just obliterated. I mean, it's beautiful, but it doesn't have that original morphology like you see in here. I did not know that. I just learned something right now, and I hope you did too. Very cool. Very cool. And I also didn't know the difference too. I didn't realize there was a cut and dry difference between, between fossilized wood and petrified wood. Pretty cool. Yeah. And this is neat. This is very, very neat. Take a look at this. The nature of dinosaurs. Hadrosaurs have helped shape the way paleontologists understand certain behaviors of dinosaurs. We've talked about this a lot on my channel. Duck-billed dinosaurs, especially Maiasaura, and what it did for our perception of dinosaurs. Basically taught us that dinosaurs were, many of them cared for their young. They had complex social lives. Very, very cool. And sure enough, there's some Maiasaura in that graphic back there. Very cool. And here are some hadrosaur pieces, presumably from South Dakota, I think. Yeah. Very cool. Very, very cool. And there is a footprint of a hadrosaur right here. It's not the most beautiful footprint around, but you can distinctly see the 3 toes. 1, 2, 3. Pretty neat. Yeah. Very cool. Cool stuff. I'm recognizing a lot of my colleagues' names here in the citations in this. Very cool. Mark Goodwin, Fredo Marquez, Dave Evans. Very cool. Neat. So let me explain what you're looking at right here. There are the teeth in there. This is the lower jaw. So you're looking at the left side of the skull. So basically, the lower jaw and the teeth. There, right there. So there's those teeth. There's the lower jaw. There's the beak at the front. And then there's the big process that goes up and like big ascending jaw process. And then part of the skull is missing right there, obviously, and the whole front of the skull, the whole like duck bill in the front is gone over here. But we've still got those teeth in there, or the teeth rows at least. Very cool. And there's some more hadrosaur fragments there as well. Nice stuff. Very cool. And from right here in South Dakota, I believe. Very cool. Very cool. All right. Now, let's take a look over here. Yeah. This is pretty cool. And this is real too. Not a cast, not a replica. That looks like the real thing. Got some theropod tracks. Very cool. Dinosaur footprints. How old are these? Take a look at the tracks on the left. How many do you see? And do you think the same animal made all these tracks? Well, not the same individual animal. Could be the same kind of animal, just adult and juvenile, possibly. Yeah. Yeah, very cool. And then this looks ornithomimid to me. An ornithomimid foot and a hand. So these are replicas, obviously. Those are casts. Really cool. Look at that classic kind of spade shape to their pedal ongules right there. And you can tell that this right here is the left foot. Because there you go, digits 2, 3, 4, and the number of bones in the toe actually corresponds to which toe it is, which is kind of a cool thing about dinosaurs like that. I'm sure it's true for a lot of different tetrapod groups, But on the second toe, the first toe is missing. So ornithomimosaurs like this, they lose their first toe. The hallux, the dew claw, is gone. They don't have it anymore. But their second toe, right there, has got 2 phalanges. Their third one has 1, 2, 3. And their fourth, the one on the outside of the left foot, 1, 2, 3, 4. Pretty cool. Pretty cool. And I don't think it's the same for the hand, because that's digit 1, 2, and 3. Or at least we call them 1, 2, and 3. Shoot. I remember talking with Dana Rashid about this at one point, about the digit numbers for theropod dinosaurs. There was this old idea that the birds are not dinosaurs people had, that like, oh, birds couldn't have evolved from dinosaurs because their finger bones have different numbers. And that got resolved somehow, and I don't remember how. I think maybe it's what we always call digit 1, the thumb of theropod dinosaurs, is actually technically their second finger, their index finger, or something. I forget. But anyway, yeah, that would actually make sense as to why they would have why they would have 2 finger bones in the first finger. So that's actually digit 2 and not digit 1. I don't know. I had to look that up. But yeah. Your chicken prints look like that Jedi jingle maker? Do they? Very cool. Yeah, I mean, shoot. Chickens are also theropods. They leave similar kind of 3-toed tracks like that. Although in chickens, I think chickens also have that toe in the back. I think their hallux, their digit 1, actually contacts the ground. So you've got 3 toes, and then you've got 1 sticking out backward too in chickens. I know a lot of birds are like that. Most modern birds are like that, from what I understand. From what I can recall. But yeah, theropods and birds. Pretty neat. So yeah, why not check the bone serial number? Very funny, Cargo Cold, very funny. Here, let's go back in time to the Triassic right here. And this guy's missing, whoever was there. But that's a cast of a Placerius skull. It looks a lot like the one we have at Berkeley. Very cool. So this is a big Dicynodont, a mammal relative that lived alongside some of the earliest dinosaurs. And then they disappear. They don't make it into the early Jurassic, as far as I know. At the end of the Triassic, they're gone. But dinosaurs make it through that extinction event, obviously, and then they take over the world after that in the early Jurassic. And that's cool. Here's an early amphibian right here. Yeah. A temnospondyle. And that looks like it's a sculpt. I don't think that's even a cast. But just gives you an idea of the size and shape of these critters. Pretty neat. Some of them have much kind of broader skulls, and that's sometimes what we call them the toilet seat-headed amphibians. It's basically just got this big, flat, round, kind of toilet seat-shaped skull. Oh no, a toilet seat cover, rather. Not the actual seat. But it's not shaped like a horseshoe, their skull. It's shaped like the cover on top. You know, nice and round. But yeah. Oh, an interesting phalang. Yeah, that might be a different thing for dogs when they have the dew claw thing. I actually don't know what's up with that. I don't know if that's related or not. Anyway, does anybody here like crocodilians? Got a cool display about them right here. There is that Postasuchus or somebody like that? One of these ancient terrestrial crocodilians. Looks like it's catching an early dinosaur form. That might be Lagasuchus or something like that, trying to get away. But yeah, there is a cast of a Postasuchus skull. Very cool. So these were the top predators around the time of the first dinosaurs. Dinosaurs were not, the big dogs on the block immediately. It takes them a while to take over. These were the guys to watch out for when the first dinosaurs were running around. Critters like Postasuchus. got some lovely crocodilian teeth from Wyoming and South Dakota. Bit of a jaw fragment. These are all Cretaceous. I've actually dug some of these up, Borealisuchus and Brachychampsa. Those are the same two genera that we have in the Hell Creek, and maybe also in the Judith River. So I'm well familiar with these guys. Found lots of bits and pieces of them, especially bits of their scutes, those armor plates that they have. And there's a modern alligator skull right there. Pretty cool. Yeah. So crocodilians, they've been around for a long time. Very successful animals. Yeah. Yeah, aren't they cute, Cargo Colt? Definitely. All right. Let's see what we got. Oh, very cool. If any of you ever have the chance to visit the Museum of Geology here at the South Dakota School of Mines, then, well, shoot, go ahead and follow them on Facebook and on Instagram. And if you have a rock, fossil, or mineral that you're curious about, you can bring in here. It's pretty cool. Yeah, neat stuff. And, ooh, we've got some fossil plants here. Take a look at these. This is so cool to see up close. One of my very, very favorite plants. Well, one of my favorite plant groups is cycads. These things have been around since long before the dinosaurs, and there's still a few species around today. And this is a fossil cycad. So this is part of the cone from the Cretaceous. It looks kind of like a big pine cone, or almost like a pineapple or something, right? It's kind of how cycads work. They've got a kind of big central cone or stem or trunk, and then you've got these really interesting kind of fronds that come off of that with their leaves. They almost look like a cross between, between pine needles and ferns or something like that. But they're not really related to either. Cycads are I think they're the oldest seed-bearing plants, the earliest seed-bearing plants that we still have today. And yeah, super cool to see. Beautiful cycad cone there. Holy moly. Got another fossil cycad here. Nice cross section there. Yeah. Very cool. Fossil palm from the Cretaceous. Some redwood cones. Holy cow, they look just like ones that you might see in Northern California today. And they're from the same genus, Sequoia. These are from the Hell Creek Formation. From Glendive, Montana. Very cool. Yeah. Seeds. And we've got a fig fruit. Yeah, I think figs are some of the oldest. That might be the group of fruit-bearing plants that goes back the furthest. Of ones that we have today that are extant. I think they might go back the furthest. Very cool. Yeah. Really neat. Some ferns. Gorgeous stuff. Very, very cool. So, I don't remember, somebody was asking me a few streams ago if there weren't grasses during the age of the dinosaurs, then what kind of ground cover plants did they have back then? And ferns are a big part of that. And you can see some of those right here. They're a little bit faint, so I hope the camera's picking them up well. But, yeah. Very cool. Fern, such a venerable old plant. Been around since long before the dinosaurs. And they're still around today. And holy cow, this is cool. So I was talking about horsetails too, and how that's another kind of plant that used to be very, very common as ground cover. There's a tree-like horsetail from the Carboniferous. Very cool. So some horsetails used to get incredibly tall, like trees. Got some of these from the Jurassic. Another horsetail right there. Bunya pine, Araucaria. Oh yeah, very cool. Like monkey puzzle trees. Same genus. Very cool. And a magnolia from the Cretaceous. We were just talking about magnolia the other day, right? Yep. Go all the way back to the Cretaceous period and further, I think. Well, no. They originate in the Cretaceous. Magnolias are angiosperms, flowering plants, so they don't go back further than the Cretaceous, but pretty cool that dinosaurs would have seen magnolia trees. Pretty neat to think about. Oh, there's a ginkgo right there too. We were talking about ginkgo leaves the other day as well, and there is one right there. Just beautiful, from the Hell Creek. It's pretty similar to modern ginkgos, right? Yeah. It's an ancestral oak, sassafras tree, birch-like plant. Very cool. Lily pad-like plant. Pretty neat. It's interesting to think about how so many of these landscapes would look so alien to us, just inhabited by different kinds of animals, but there would have been lots of familiar things as well. Stuff like magnolias and ferns and, I don't know, ginkgos, crocodiles in the swamp still, and turtles and things like that. So even if you were to find yourself in the Cretaceous period, it's not like everything would be alien to you. Not everything has completely changed since back then. Which is cool to think about. Yeah. And OMG milkshakes. It's amazing how some things have survived for so long. Agreed. Yeah, pretty cool. Although it's also a reminder that in the grand scheme of things, the age of the dinosaurs wasn't really that long ago, you know? The Earth is 4.54 billion years old, and the last of the non-avian dinosaurs only went extinct 66 million years ago. So, yeah, it just kind of puts things into perspective, you know? And shoot, speaking of cycads, like we were just a minute ago, I think we've got a living cycad over here. Yeah, check this out. Who is this guy? This is not Cycas revoluta, the most common modern cycad in cultivation. This is something else. I don't know who this is, but as you can see, there's that central cone there. And then you've got those fronds all growing toward the light. Poor thing. Yeah, very cool. I wonder who this is. This might be genus Diune, like Diune spinulosum or something like that. It looks similar to the one that we had at Berkeley. Yeah, very cool. But yeah, and what's this right here? Anybody have any guesses? What are we looking at the back of right here? I wonder if anybody could tell me. Who thinks they know? Oh, Murph, you got that exactly right. Yep. This is good old Dunkleosteus right here. This giant placoderm fish from the Devonian, I think? Silurian? I forget when exactly it lived. We'll look at the display. But there's the eye right there. There's this big set of choppers. Truly extraordinary fish. It looks like they have a representation of the animal when it was alive right there. Yeah. It lived during the latter part of the Devonian, the age of fishes. So it's about 360 million years old. So this again is from long before the dinosaurs. Very cool. And I mean, look at that. Look at that beak right there. So this is a cast. This is not the original. Do you see how they've kind of put some screws straight through, along with that armature to kind of hold everything in place? Yeah. for an original fossil, you would have kind of a metal armature with like what we might call fingers or antlers kind of holding the actual elements in place. When you're just using a cast like this, you can just drill straight through, which gets a lot easier. You don't have to custom weld this great big antlery thing to hold everything in place. So pretty neat. Interesting the use of tan bark in here. It's like redwood bark, something to. Yeah, it's an interesting choice. It works. Yeah, pretty cool. Pretty cool. Yeah. Pretty neat. And welcome, Trappy. Good to have you here. Glad they aren't drawing the fish with teeth on the outside anymore. Did that used to be a thing for placoderm fish, drawing teeth on the outside? Anyway, let me just put this in front, give you a sense of scale. Right here with Dunkleosteus. What a big fish. At the time that these guys lived, they were probably the biggest predators to have yet evolved on planet Earth. About 370 million years ago, or whatever that was. They've since been surpassed multiple times, but I don't know, they're still pretty intimidating. Pretty cool. Pretty cool. So yeah, I'm realizing I've been kind of going backwards in time, which is appropriate. Let's go forwards a bit now, and let's talk about this critter right here. Let's talk about the mosasaur. So this, I've been waiting to show everybody this. This is a mosasaur. I wonder if we actually have a genus and species for this guy. But mosasaurs are giant ocean-going lizards. They lived in the Cretaceous period. They're not actually around for all that long. I think they show up in like the mid-Cretaceous, when they really kind of take over. They're the biggest oceanic predators in the late Cretaceous period. Yeah. And like I said, they are giant ocean-going lizards. So this guy seems to be pretty closely related to varanid lizards, monitor lizards like the Komodo dragon, critters like that. You can see that in the morphology of their skull. We were looking at this earlier. They've got those big lizardy teeth, lizardy nostrils, and I don't know if you can see it with this camera, but if you look underneath, look toward the back of the mouth, protruding downward are the palatine teeth. So these critters actually have teeth on the roof of their mouth, protruding downward, probably to help capture slippery fish and stuff like that, make sure they can't get away. Pretty neat. Very cool stuff. Right here, we've got a swimming paddle from a short-necked plesiosaur. This is probably from Polycotylid, maybe? It doesn't say what age it is. But somebody was asking about the phalanges. Why do they have so many? Yeah, why do they have like 20 fingers and one fin, says Cargo Cold? I mean, this is something that I think almost all marine reptiles do. Maybe even all of them. I think sea turtles do the same thing, where I guess it's not all that difficult to just multiply the number of bones in your limbs like that. And these guys certainly do that. I mean, take a look. Right here you've got I think that's the humerus right there, radius and ulna, carpal bones, and then the phalanges. And there are a lot of them. This doesn't even have all of them. Some of the distal ones are missing over here. But you can see there's a distal one right there from the end. Very cool. So yeah, I don't know, kind of multiplying certain bones like that. It's not difficult for reptiles to do for whatever reason. Like when we look at our elasmosaur right here, look at the number of cervical verts it's got, the number of bones in the neck, those neck vertebrae. I think these guys actually hold the record for the most cervical vertebrae of any animal that's ever lived. It might be Elasmosaurus or it might be Thalassomodon or something like that. But these guys, they can have over 70, maybe even over 80 neck vertebrae, which is crazy. Very, very cool. Very cool. So yeah. And Cargo Holt says maybe that answers the thing with bird's fingers. I don't think it does, no. Well, I don't know. I'd have to ask an expert about that. I'm not sure. But yeah. No, and I am excited to look around at some of that stuff. We've got a Rex skull right there. Tyrannosaurus. Very cool. But for right now, let's scoot around and just take you on a journey past this mosasaur. And you can get some appreciation for that kind of sinuous shape of its body. Very cool. The number of verts on these guys is just nuts. It really is almost kind of snake-like, right? There was an idea a while ago that maybe mosasaurs were the ancestors of snakes, but I think that idea's kind of fallen out of favor. I think that snakes probably had a fossorial origin, so they probably evolved from burrowing, legless lizards rather than something ocean-going like mosasaurs. But yeah, pretty cool. Pretty cool. Check out those hind flippers there. Probably mostly used for stabilization rather than propulsion. These guys aren't like kicking with their flippers. They're kind of used as like stabilizers or rudders. The tail is the primary means of propulsion. You can see that kind of flattened tail. It's flattened from side to side. Perfect for sculling, kind of like a crocodile swims, kind of sculling its tail horizontally like that. Pretty neat. Pretty neat. Now we know who took all the neck versus coconut. Yeah, and that hadrosaur over there, that's Edmontosaurus, I believe. And we'll talk about that Edmontosaurus in just a little bit, Smorphosaurus. Give me just a few minutes. Let's read this sign on the mosasaur here. So this says Mosasaurus conodon. Belongs to a group of long extinct lizards known as mosasaurs. Shoot, this is just rehashing some of the stuff I was already telling you. This is the geologic history of the mosasaurs is relatively brief, in spite of the fact that they became widely distributed over the earth in great numbers and moderate diversity. Moderate diversity, okay. But yeah, these guys lived in that ancient seaway in the middle of North America. You know, places like Kansas and Nebraska and North and South Dakota, and Montana and Wyoming. All of that was covered by a shallow sea. In fact, shoot, here it is right here. I used to have this poster in my room when I was a kid. But this, I guess, is from the late Cretaceous period, probably about 90 million years ago. And so here is North America. This is before Florida was land, before most of California was too. Here I am in South Dakota, right there. And so this is the WIST, the Western Interior Seaway. And this kind of expands and contracts and ebbs and flows and advances and retreats at various times during the Cretaceous period. But that is when critters like these mosasaurs and elasmosaurs were swimming around. And then by the very end of the Cretaceous, this almost entirely closes up. There's just a little bit of it intruding up here, and then the rest of this is land. Dinosaurs like T-Rex and Triceratops are walking around at that time, and we're going to see in just a minute over there. So yeah, I hope that makes sense, provides you a little bit of context. But yeah, John Civic Paleoart, there you go, Daikaiju, yeah, you're exactly right, poster. And you were underwater in Dallas back then? You were, Sepharix, yeah. Yeah, pretty cool. So that was the environment these guys were swimming around in. And I suppose that's why we know about them, is because if they lived out in the open ocean, then we wouldn't really have their fossils, because they wouldn't be on land today. But since that was an ancient seaway in the middle of North America that has since dried up, we can find their fossils. Pretty cool. So it kind of makes you wonder if out in the big open ocean there are mosasaurs that are twice as big or something. We certainly don't know yet. All the fossils we have are from kind of shallow inland seas for the most part. Pretty cool. Pretty cool. Let's go back around this way. Let's take a look at this mosasaur from another angle, and then we'll get into our dinosaurs. So hang tight, everybody. All right, check that out. You can see those fins kind of splayed out to the sides, those flippers rather, kind of acting as rudders, which makes sense. It's kind of like, I wonder if that's kind of like the skeg on a kayak, you know, that kind of rudder thing that goes downward, so that when you're paddling from side to side, it kind of keeps you going straight. I bet you that's what those fins were for. Kind of acting as a rudder like that. Or rudders, maybe also acting as dive planes, like on a submarine. Very cool. Take a look at that skull. Very cool. And look, I think you can just barely see the palatine teeth on the roof of the mouth right there. Really neat. Very cool. Oh, and we got a big raid. Renoa Poison, thank you so much for the raid. Really appreciate that. Welcome. Renoa Poison says, where are the dino nuggets? I don't know, your local fast food place, I guess. Right now, I am at the South Dakota School of Mines Geology Museum. I'm in the middle of this great big road trip going all across the U.S. and stopping in various places and live streaming, so welcome. If anybody is new here, welcome to Paleontologizing. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch trying to do some good old-fashioned science outreach. And later this summer, I'm going to be doing some field work, digging up some dinosaurs in Utah, and I hope to be streaming that. But for right now, I'm just kind of tooling around, visiting different museums, and introducing people to these incredible fossils, like this Brontothere right here. This big ancient mammal from after the extinction of the dinosaurs. There's a tip. If you ever see a big mammal fossil, you know it's from after the dinosaurs. Because mammals don't get big until after the dinosaur extinction. Oh, and somebody was promised dinosaur nuggets. Well, shoot. I can tell you this. Let's go in front of this dinosaur skeleton and talk about that. Maybe Renoa was already talking about this, but if you ever eat dinosaur chicken nuggets, not only they're shaped like dinosaurs, but it's actually true. They are made from dinosaur chickens, like all birds, evolved from theropod dinosaurs. And so not only is it shaped like a dinosaur, it's actually made from dinosaurs. Interesting to think about, right? And thank you for the Prime. Who is that? M. Oculus. Thank you for the 11 months. Really appreciate that. That is lovely. Yeah. And Elik there. Hey, thank you for being here. I appreciate that. And thank you again to Renoa Poison for the raid. Really appreciate that. Renoa, I hope you had a wonderful stream. It was great to have you here. Thanks for bringing all your viewers. Holy moly. And if anybody wants to help me pay for gas and stuff on this trip, consider subscribing. If you've got an extra Prime lying around, I'd really appreciate that. Or some bits or whatever. This is all in the interest of science outreach and, trying to educate people about the incredible history of life on our amazing planet. So Is that a young Hadrosaurus cargo cult? This one here? No. This is going to be pretty close to fully mature. So this is a super old mount for this animal right here. Yeah. Can anybody tell me why this is an old mount? What is old and outdated about this? We'll talk about how our understanding of dinosaurs has changed since this was put together probably in the 40s or 50s. And holy cow, Jody Fish, thank you. Orchid Twilight, 10,000 bits. That is incredible. Thank you so much. Really, really appreciate that. Holy cow, Orchid. Thank you. That is amazing. Holy moly. Yeah. And yep, we've got some people with the correct answer. Oh, thank you, Anonymous Cheer, for the 100 bits. Really appreciate that. Thank you. So this hadrosaur right here, this big duck-billed dinosaur. Oh shoot, it talks about it right here. Very cool. It should, like this, if you were to look up Edmontosaurus on Wikipedia, you'll probably get that same exact illustration. Yeah, very cool. This artist has done so many different illustrations of ancient critters and made them freely available on Wikipedia, and I wonder if they know that it's now on display in this museum. Probably in many museums. But anyway, yeah, this is a classic kind of upright pose for this animal, standing kind of on its tippy toes, and it's got its back, held aloft, almost like a kangaroo or like Godzilla or something. Its tail dragging here on the ground. Completely wrong. We now realize that this big tail, not only can it not bend like that, there's actually going to have to be a few broken bones in the tail in order to get it to bend like this. Let's see if we can spot them. Some of those neural spines. Some of these are reconstructed, I guess, so they wouldn't have to be broken. Oh, right there. There's a break right there. And there's another one right there. Yeah. The tail can't actually bend like this. Yeah, we now realize that massive tail is a counterbalance to the front of the body. So this animal would have actually held its spine kind of parallel to the ground. Like you see in this illustration here. So the tail sticks out straight behind as a counterbalance. And these animals probably walked on all fours the vast majority of the time. Even though their forelimbs are not nearly as robust as their hind limbs, they probably walked on all fours most of the time, but if they wanted to, they might have been able to kind of rock back on their hind legs and run just on two legs like that. But very, very cool. This gives you a sense for the scale of the animal, too. This is actually the biggest dinosaur in its environment. It's even bigger than T-Rex. In the Hell Creek Formation, Edmontosaurus is the biggest dinosaur. And even though this is an incorrect mount, we now know that this is completely out of date. It's still beautiful. I mean, just the bones of the animal itself, just that skeletal architecture is just exquisite. Very, very cool. And I like how it's mounted to the ceiling. Hold up the head. Nowadays, if you were to do a mount like this, you would have supports come up from the ground, and yeah. You can see why they haven't actually updated the pose on it. It would be way too much work. In fact, that might even be like, I don't know, tied into the structural support for the building. Who knows? But yeah, that would make me nervous. Yeah. And masculine, can you imagine them just boinging away from a T-Rex like a kangaroo? Yeah, this animal's way too big and heavy for that. I mean, it barely works for some large kangaroos. It would not work for a dinosaur like this. Yeah, pretty cool. Here, let me walk underneath the front just to kind of give you a sense of scale here. That is pretty amazing. Pretty amazing. Edmontosaurus, biggest dinosaur in the Hell Creek Formation. And now this is not actually a full-grown individual. I mean, especially if the if the skull there actually goes with these elements. Because we've got bigger skulls, what we used to call a natatitan. The skull gets really long and really flat toward the end of the animal's life when they're like fully mature. And it doesn't look like this guy is there yet. I mean, you take a look at that skull and it's still fairly tall at the front. I've definitely seen bigger Edmontosaurus skulls. So this animal's not actually full grown yet. Kind of amazing to think about. You know, it's like bigger than an elephant. Yeah. So according to the sign, this specimen is a composite mount, which means it contains both real fossils and reproduction casts of real fossils. Many restorations of animals are done this way, fossil animals are done this way, because it's very rare for paleontologists to find the whole animal. So the actual fossils in this specimen were found in the Upper Hell Creek Formation sediments near Watauga, South Dakota. Interesting. Upper Hell Creek. Huh. Very interesting. Pretty neat. Pretty neat. Yeah. But yeah. And Ferguson. Yep, dinosaur looks structural. Gonna need an engineer to fix this. I mean, yeah, look at how it's mounted to the ceiling. Like that. Yeah. I don't think they ever intended for this thing to be moved. What's crazy is I think this tibia right here, that's original bone in there. And they just drilled straight through it with a metal support. Man, what a wild time, the early 20th century, for mounting dinosaur skeletons. You just drill straight through the fossil bone to put a metal rod through it. You don't see this kind of thing today. Today, if you're going to mount a real dinosaur skeleton, if you're going to have the real fossils, standing up like this in a display, then you would have this kind of complex framework of, like a metal armature that holds the bones in place. You don't just jam a metal rod through the bones. Yeah, that's pretty wild. That's cool. I can pick out some of the parts that are reproduced and some of the parts that are sculpted and some of the parts that are genuine. So like the femur, almost all of that looks real, except for maybe that bit there. The ischia look like they're just sculpted, except for maybe the proximal end right there. Yeah, this ischium right here, these bones in the back of the hip, the one closest to us, that's all sculpted, I think. Some of these vertebrae, and especially those caudal chevrons, are definitely sculpted. But good parts of this look like they're the real thing. But of course, it's all painted the same color, which again was common practice back in the early 20th century. We don't do that kind of thing today. Nowadays, we try and have at least a subtle difference between the color of the cast or the color of the the part that's been sculpted to fill in the gaps and the actual fossil. We don't want them to look identical because, I don't know, it almost kind of feels dishonest. And you want people to be able to tell which parts are real and which parts are reproduced if they're looking really closely, So yeah. And let's see, did we just get another raid? Well, holy cow. California Burbs. Thank you so much for the raid. I really appreciate it. Welcome, California Burbs. We're looking at some South Dakotan bird ancestors today, including this guy. Take a look. Tyrannosaurus. Everybody's heard of this guy. So this is a cast of AMH 5027. So the original is at the American Museum of Natural History in New York City. And it's one of the most famous Tyrannosaurus skeletons in the world. In fact, You know the one in the Jurassic Park logo? I think that's AMNH 5027. Yeah, no, it is. You could tell. Yeah, very cool. So there's the former president of South Dakota School of Mines with the T-Rex skull in the early 1940s. I guess that's what the museum looked like back then. Very cool. So yeah, how's that to greet you after a raid? Thank you again, California Burbs, for the raid. That's wonderful. But yeah. And Green Herring says, I don't think California Burbers would have enough seed for that guy. I don't think so either. Yeah. Holy cow. But dinosaurs like Tyrannosaurus are very closely related to modern birds. The group of dinosaurs that T-Rex belongs to, called theropods, is the same group that birds belong to. And if you type in !turkey into chat, then you can pull up a cool little infographic that I put together comparing a skeleton of a velociraptor, which is another theropod, to that of a turkey. And this kind of lays out all these different features that birds inherited from their dinosaur ancestors. Everything from their lungs to their wishbones to their feathers. Those are all dinosaur innovations that birds kind of received as hand-me-downs. Pretty neat. So yeah, T-Rex. Pretty cool. Yeah. And here, of course, is one of my very favorite dinosaurs. And this is a genuine skull right here. There are some bits that have been filled in, but for the most part, this looks like this is real bone. This is Triceratops. Check that out. So this is Triceratops prorsus right here. And it's not fully mature, so it doesn't have that great big nasal horn just yet. But yeah, you can see those big stocky bases to the brow horns there. That's characteristic of Triceratops prorsus. Very cool. Now, Triceratops is one of my very favorite dinosaurs because I've dug up, probably like 20 or 30 of them over the years, working with Museum of the Rockies and the Carter County Museum and Badlands Dinosaur Museum, museums like that. They are everywhere in the Hell Creek Formation. So it's very appropriate that they have one here at the Museum of Geology in Rapid City, South Dakota, because Triceratops lived right here. We've got Triceratops fossils from South Dakota. Yeah, very cool. And this is actually South Dakota state fossil. Pretty neat. Although they got that part wrong. This is not Triceratops horridus. This is Triceratops prorsus. Again, you can tell by how thick the base of the brow horns is. Yeah. Pretty neat. And take a look at that frill texture. You see these kind of rivulets and grooves that are running up it like that? These are what we call like blood vessel grooves. If you look at the texture on, say, like a toucan skull or a hornbill or something like that, you know, these birds that have very elaborate big beaks that are very brightly colored, they've got a similar kind of texture. I mean, shoot, do like a Google image search right now for like toucan skull or hornbill skull, especially. And you will see those same kinds of grooves, you know? And so just like a hornbill or a toucan, these guys probably had a kind of a keratin sheath over the surface of this. So keratin is the same kind of material like a bird's beak or like your fingernails. They probably had a similar kind of material coating just about anywhere you see those grooves. So here on the frill, and there around the eyes, and up on the horns, and maybe even over the front of the face too. These grooves are just everywhere on a trike skull like this. And so in life, these animals probably had some really, really bright coloration on their heads. It's pretty cool to think about. Yeah. Optic nerve says, do you believe they shed layers like birds do with their bills? Probably optic nerve, yeah. I mean, anything that's keratin like that, generally, like, it requires a lot of nutrients in order to maintain those colors, and also stuff kind of sloughs off. So yeah, I wouldn't be shocked if these guys were like constantly shedding parts of their frill, just the surface bits, you know. So yeah, and vascularity. There you go, Golganek. That's the word, vascularity, for that surface texture like that. Very cool. Now this is actually, I wonder. Since this is from the Upper Hell Creek, I think, which makes sense because it's Triceratops prorsus. But something about this makes me think that it's really mature. Check out the epis on this. So the epis are the little bones, kind of the little spike bones around the perimeter of the frill. And so here we've got the episquamosals attached to the squamosal bone right there, and the epiparietals up there attached to the parietal bone. And you see here, rather than being like kind of, you know, sharply triangular, like Dorito shaped like they are in younger Triceratops, these are nice and kind of squashed flat, and they're like starting to fully fuse on to the perimeter of the frill. See that? It's like really difficult to distinguish where the epi begins and where the frill begins, where the frill ends. And that is a characteristic of an older, more mature specimen. If you look at like fossils of really young Triceratops, the epis they're not really fused on at all. They're also really pointy. Here they're nice and squashed, and that's a characteristic of a mature animal. So pretty cool. If we wanted to figure out exactly how mature it was, then we could cut into it. Usually the tibia is the best bone for that, but any kind of limb bone or maybe even ribs, if you know what you're doing, will also work. You can basically cut the bones open and create a thin section slide, look at them under the microscope and count the growth rings, almost like you might do with a tree, to figure out how old the animal was. We call this histology. There are lots of people who use this method in modern critters, use histological methods for figuring different stuff out, but that's what we can use for figuring out how old a dinosaur was when it died. Which is kind of essential, because if you're trying to figure out if, is this a new species, or is it just, you know, maybe a fully mature or juvenile individual of a species we already know about, it helps to know how old the thing is, you know? So yeah. And Wondergoon says, no, it's not a dumb question at all. It's a great question, Wondergoon. There have been a lot of hypotheses over the years for what ceratopsian dinosaurs like Triceratops would have used this big frill for. Like, why did that evolve in the first place? You see it here. There was an idea that maybe it was for thermoregulation, that maybe the animal used the frill to warm itself up in the morning or cool itself down. Which maybe it would have worked a little bit for that. There was an idea that maybe it was like armor plating in order to protect its neck. Because you see right here, there it is over the neck of the animal. It's kind of hard to bite the neck when you've got the frill right there, I suppose. But the thing is, it's actually really thin. If we look along the back, well, we've got that plaster support under there, so you can't really see, but just trust me when I say it's very thin. It's like this thick, maybe at the thickest, toward the center of the frill. And in some of these animals, when they're fully mature, it thins down to just about nothing. In fact, in some of them, it probably disappears altogether in the middle. You just end up with a big hole that would have been covered with skin and keratin and life, but yeah, there's hardly any bone there. So it wouldn't have been very good for armor either. So what was it for? The answer seems to be for display. And the horns also may have been used a little bit for defense, but also are probably mostly for display. The thing is, both the horns and the frill, they change a lot as the animal is growing and developing. And so it looks different at different stages of growth. And for whatever reason, it seems to have been really important for a lot of dinosaurs like Triceratops to be able to tell who is old and who is young. It could be that they're living in kind of age-segregated herds. So like individuals of the same age are all hanging out together, you know, in the same environment, eating the same thing, looking out for each other. Kind of like in a high school, you might have all the, you know, freshmen hanging out with each other, and, you know, the seniors like don't want to go near them. Maybe it's the same thing with Triceratops. But yeah, it seems to be for display, and that's why you've got that vascularity too. It seems that this would have been coated with keratin, and probably been really brightly colored, almost like the bill of a toucan or the casque on a hornbill or something like that, you know? So yeah. And Oliver says, are there any other people standing around listening to you dump knowledge? No, there's almost nobody else here, which is kind of a shame. Like, this museum should be packed. This is so cool. And it's free admission as well. I don't know why more people aren't here. But, yeah. That will happen later on in the summer, though. I will get crowds of people surrounding me, like happened last summer. So, just you wait. Yeah. And Wondergoon says, so the horns and frills serve the same purpose as a peacock feathers, then. Neat. Kind of, yeah, for display. For peacocks, though, there's a distinct difference, and that only the males actually have those big showy feathers. The females don't. With Triceratops, both the males and females have these crazy horns and frills. So it doesn't seem to be for sexual display, at least not like in a sexual selection kind of sense, where you've got strong dimorphism. It seems to be something kind of more basic than that. Yeah. Anyway, pretty cool. Here in South Dakota, with South Dakota's state fossil, Triceratops. Pretty neat. Although they really should change that. This is not Triceratops horridus, it's Triceratops protus. Cool stuff. And Joshua Sweet, there's only 12 people in South Dakota. Well, Joshua Sweet, shoot, when I was at Mount Rushmore yesterday, there was a lot more than that. Holy cow. Never seen something be so crowded in South Dakota. Yeah. And you know what, it was cool. I mean, well, I don't know, frankly, I can't say this too loudly, so, but Mount Rushmore, kind of a disappointment, you know? I mean, I'm going to let you in on a little secret. Somebody carved that thing, you know? It's not even naturally occurring. I don't get what the big deal is. Anyway, something that is a big deal and naturally occurring is this right here. Check this out. We've got Antarctic fossils. Very cool. A baby/juvenile plesiosaur from Antarctica. In 2005, an expedition founded by the NSF, National Science Foundation, Office of Polar Programs, led by Dr. James E. Martin, Paleontology Program Coordinator from here at the School of Mines. One of the participants, Dr. J. Foster Sawyer, South Dakota Geological Survey, found the skeleton on Sandwich Bluff, Vega Island, weathering from ashy sandstones that represented a near-shore marine environment at the end of the age of dinosaurs, approximately 70 million years ago. The skeleton is one of very few baby plesiosaurs known worldwide and is the best fossil skeleton known from Antarctica. Very cool. Holy moly. That is amazing. Everybody, you are looking at the best fossil skeleton known from Antarctica, and I assume that is of any critter. We've got a few dinosaurs from Antarctica now. We've got, I think, some dicynodonts and stuff like that. But this is pretty extraordinary. A juvenile plesiosaur from Antarctica. At the time, Antarctica would have been a little bit further north and a lot warmer than it is today. There were plants that grew on Antarctica at the time. Things like ferns and cycads and stuff like that. I don't know if I would call it tropical, but it was certainly warmer than it is today. And there is a lovely, lovely skeleton. You can see those ribs crisscrossing it. Looks like we're looking at the ventral side. So we're like underneath the animal, looking up at it, basically. So those are the belly ribs, the gastralia underneath. You can see the vertebrae there. These are the hips, right here. So this is where the hind flippers would come off of, and that might even be the articular, ball of the femur right there. Very cool. And those must be the ilia right there too. Or no. If it's on this side of the hips, those are probably the ischia and the pubes, I guess. Yeah. And up there you've got some of the neck vertebrae, I guess. Just starting with the cervical vertebrae. And that might be a humerus right there. And those look like they're probably the coracoids. So the like, up by the the shoulder girdle. Very cool. And that's probably a humerus right up there too. Very cool. I wish they had a diagram here so that we can figure out what's going on, but this is pretty awesome. Pretty awesome. And this says, please open drawers slowly, fragile fossils inside. Are we supposed to open these? Oh, we are. Very cool. Take a look at that. We've got a mosasaur paddle from Buffalo County, South Dakota, from the Pierre Shale, I assume. So this is a paddle of a mosasaur like this. It's ocean-going lizards. Very cool. And and hang on a second. Looks like we're getting a raid from Geo Jim. Geo Jim, how are you doing? Welcome. Back to Paleontologizing. Thank you so much for the raid, and everybody, if you're not yet following Geo Jim, consider doing so. Does geology here on Twitch, and it's always super cool. Geo Jim, I'm here now at the Museum of Geology at the South Dakota School of Mines right now, and having a grand old time. This is fantastic. So glad we stopped by here. Very cool. Got this super old mount of a duckbill dinosaur here, Edmontosaurus, Triceratops skull, Tyrannosaurus, and an Antarctic plesiosaur right here. An Antarctic juvenile plesiosaur, no less. Very, very, very cool. So yeah, it's great to have everybody here. I hope you stick around. Yeah. And Michael C. says, are they still digging and finding a bunch of new fossils all the time? Or do museums just trade and buy from each other? No, we find new fossils all the time. Holy cow. I'm going to be doing that later this summer. I'm going to be doing some field work down in Utah. And hopefully, if everything works the way it should, I'll be streaming it so that you can actually tune in and see what it's like to dig up dinosaurs live on Twitch. So yeah, we're always finding new fossils all the time. In fact, sometimes, I don't know, at least when we have funding. And sometimes even when we don't, sometimes we put up our own money for funding. That's what my friend LJ does. And Maskling. Yeah, we can talk about that for a second. Sure. And Zico says it's still amazing to think those dinosaurs roamed the planet. Isn't it cool? Yeah. Let's see if we can find the artist for this painting over here of the two saber-toothed cats fighting each other. I am not sure who painted that. As a tribute to the memory of Professor James D. Bump. This mural was copied and enlarged from Bruce Horsfall's original and donated to this museum by his friend Maurice I. Rappaport. Very cool. Bruce Horsfall, I think, is the original artist. Yeah. So you can look that up if you'd like. Very cool. Yeah. And Issa Tatoku, how are you doing? Welcome to Paleontologizing. Yeah. And you're welcome, Maskling. You're welcome. Yeah. Very cool. And here, we keep missing this too. Here, before we get to our marine reptiles again, let's check out this critter, Xiphactinus. We were just talking about this critter in depth. We did a non-dinosaur deep dive on this big little fish just a couple weeks ago. I mean, check that out. That's got to be, 15 feet long? Like 4 meters, almost 5? Maybe longer. Very, very cool. So this is at the same time that we had mosasaurs and plesiosaurs swimming around in the western interior seaway. We had these big old fish cruising around too. I mean, just extraordinary. Xiphactinus audax. It is the longest known fossil teleost or bony fish. This specimen was found in 1925 by W.L. Dillon, 6 miles east of Hot Springs, South Dakota, in the Niobrara Formation. So the Niobrara is from... It's actually a little bit earlier than some of these guys. I think these are from the Pierre Shale. Yeah. So these are like late Cretaceous. This guy is a little bit earlier, still in the late Cretaceous, but a little bit earlier. Very cool. About 90 million years ago, this fish swam in a shallow seaway which covered the interior of North America. Yeah, just like we were showing. Let me show you that diagram again over here. For anybody who just rated in, North America used to be covered, in its interior at least, by the WIST, the Western Interior Seaway. And there's Xiphactinus right there. This big old teleost fish. There are also giant sea turtles, giant marine lizards like this mosasaur, and big old marine reptiles like that elasmosaur. Elasmosaur, as you can see right here, and mosasaur, like we have right here. Yeah. Very, very cool. So yeah. And Hugin, you got to talk with Thomas Holtz this morning. Oh, that's cool, Hugin. Very nice. Yeah. But yeah, and Jody Fish, I'm not going to forget to close the drawer. I'm not done with it yet. So here we've got a front paddle of a mosasaur, and you can see that really interesting arrangement where you've got, let's see, are these backwards? What's going on with this? Maybe I'm just looking at it wrong. I guess that's radius and ulna, or radius and ulna, and then carpals, and then phalanges. I don't know, I'm confused by that. I wonder if that's actually the proper arrangement. And there we go, you've got a scapula and a coracoid. So a shoulder blade and like I guess one of the collarbone type dealies. Let's see what's in here. Ooh, check that out. And you can see here, this is what we call a cradle that we build around these fossils in order to help keep them nice and snug in the drawers, to keep them from rolling around, because they can become damaged that way. But very cool. What you're looking at here is a ventral view of a skull. So this is the roof of the mouth. You're looking up into the roof of the mouth right there. There's those teeth. And then it's like the palatine teeth are missing. But still very, very cool to see. And there, right there, is a pterygoid fragment. That might be with the palatine teeth right there. I think the pterygoids might be those bones in the middle with the palatine teeth. So yeah, these critters had teeth on the roof of their mouth. Pretty gnarly when you think about it. It's pretty cool. And again, these are giant marine lizards, mosasaurs, that lived alongside the dinosaurs, except in the oceans. And holy cow, there's a pectoral girdle, I can tell that, from a juvenile elasmosaur. Very nice. One of these long neck guys like that. Very cool. So scapulae and coracoids. You're basically looking at like the chest of this animal. Very cool. Now, we used to think these critters would have crawled up onto land in order to lay their eggs, just like modern sea turtles do. And so it was thought that, oh yeah, they've got these, pectoral girdles that are reinforced in order to, keep themselves from suffocating when they go up onto land. And then a few years ago, there was a specimen discovered of a female plesiosaur, short-necked plesiosaur, and she was pregnant. She had an embryo inside her, a big one. It couldn't have been something she ate. It had to have been a juvenile. And then after that, we started to realize, holy cow, these things gave birth to live young. They didn't lay eggs at all. So they presumably never would have had to go up on land at all. So the whole thing about their shoulder girdles being like reinforced, maybe that's to help keep the water pressure from crushing their lungs or something, but it doesn't seem to be an adaptation for moving around on land at all. So yeah. But yeah. And Isada Toku, is the road trip count gifted subs or money donations? It's just subs, gifted subs, yeah. Anyway. And, this one's empty here. Okay. Cool. Well, speaking of plesiosaurs, let's take a look at this big skeletal mount over here. And then I think we'll maybe get ready to wrap things up. So, I wonder if this is Elasmosaurus proper, like Elasmosaurus platyurus. Take a look at that neck. Just extraordinary. And there's the pectoral girdle, like we just saw in the drawer. So as you can see, it's not really as robust as you would imagine for an animal that would have been like, hauling itself across the beach in order to lay its eggs. So it makes a lot of sense nowadays. Now that we know that these critters gave birth to live young, it makes a lot more sense than it used to, given the architecture of their skeletons. And look at all these phalanges there in the rear flipper. When I think of elasmosaurs like this, I think of different elements in the skeleton kind of multiplying. We were talking about how long its neck is. These guys hold the record for the most cervical vertebrae of any animal, so the most vertebrae in the neck. And I'm kind of tempted to count them, but I don't know if that'd be interesting content right now. And also, I'm not entirely sure where to draw the distinction between dorsal verts and cervical verts, so that's going to affect our count. Maybe right there? Well, shoot, let's just go ahead and do it. We'll count the number of cervical verts. I seem to recall that Elasmosaurus platyurus is supposed to have 72, I think? We'll see how many this critter has. All right, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and then 22 has that support coming off of it. Here. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34 has got those white specks. 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, and 57. 57 counting the atlas and axis vertebrae. 57. I wonder if I started the count too late. I wonder if some of these are actually cervicals and not dorsals. Anyway, holy cow. 57. Does anybody in chat know how many vertebrae they have in their neck? A human being, how many vertebrae do we have in our necks? How many cervical verts? Somebody let me know. Anandusha, welcome back. Good to see you. And yep, if you typed in a 7, or if you said to the screen 7, then you're exactly right. We've got 7 vertebrae in our necks. Compare that with 57 on this critter. So this is, of course, a very long-necked animal. Can anybody tell me in chat how many cervical vertebrae a giraffe has? How many verts does a giraffe have in its very long neck? Oh, you got to see your 7 vertebrae in an X-ray. Very cool, Anina. Very cool. So you got to count them firsthand. And yes, giraffes also have 7 neck vertebrae. Almost all mammals do. For whatever reason, mammals just, they can't really change the number of neck vertebrae without other stuff going very badly wrong during embryology. It's like it causes fatal birth defects, it seems. But for critters like elasmosaurs, it doesn't matter. In fact, I think there are members of the same species that actually have different numbers of neck vertebrae for plesiosaurs like this. It just doesn't matter. They can keep multiplying their neck vertebrae and it doesn't break them like it does with mammals. which is really interesting. Same thing, I bet, as with the flippers. Look at all the phalanges on these guys. Look at all those different finger bones. So you've got your humerus up there, your upper arm bone. Then you've got, it must be the radius and ulna, unless they just do away with those, unless they're the carpals. But I think those are the carpals, the wrist bones. Yeah, they look very carpally. And then here are the phalanges right there. Look at all of those. So many. It just doesn't matter. They could just multiply them and everything still works out. Pretty cool. Pretty cool. I guess they don't have to worry about articulating them and flexing them or anything, so they could just have as many as they need. Pretty cool stuff. And this is Styxosaurus, apparently. Which is the same as Alzadasaurus. I recognize that name. That's named after Alzada, which is a tiny little town near Ekalaka, Montana, in the southeast part of the state. So I guess Alzadasaurus was found to be the same thing as Styxosaurus. So anyway, very cool. Yeah. This skeleton, Styxosaurus snowi, approximately 36 feet long, was discovered in 1945 by Mr. Arthur Salzman on his ranch near Iona, South Dakota, in the lower Pierre Shale. These deposits were formed in the late Cretaceous time in a vast sea which covered a considerable part of central North America. We were talking about that earlier, that western interior seaway. Yeah, pretty cool. In 1945. Pretty awesome. And it was probably mounted not too long after that, too, I'd imagine, because like our Edmontosaurus over there, this has a similar issue where both the reproduced parts and the actual fossils are painted the same to look like they're the same color, which is kind of confusing. And they've got metal supports that are like running through the bones. It looks like through the actual fossil material. We wouldn't do that kind of thing nowadays, but it was common practice back then. They did it all the time. So yeah, pretty neat. And now look at that kind of short, stumpy tail too, right over here. Very cool. What a contrast between that super long neck and this pretty short tail right here. In recent reconstructions that I've seen, these guys actually have like a vertical fluke, like a rudder basically, on the end of their tail. I don't know. I don't work on plesiosaurs, so I'm not really up to date with that kind of thing. But I've seen that more and more. I think they're shown with that in Prehistoric Planet, and they generally got pretty much everything right. So that probably is the modern consensus, is they did have kind of a fluke on the end of the tail that would go vertically like that to help stabilize them in the water. So unlike the mosasaur that we have back there that would propel itself by sculling its tail back and forth laterally like that, these guys, it's their four flippers that they use for propulsion. And it's still not super clear, it seems, how exactly that worked. It's odd because we don't have any modern animals that have two pairs of flippers like that. We can't really compare it to anything. Penguins, just have one. And they kind of fly by, they kind of swim, they propel themselves through the water by kind of flying through the water. They kind of flap their flippers, their wings, whatever you want to call them on a penguin. These guys are almost like double penguins. So do they work by, I don't know, kind of going with all four flippers, like synchronously like that, all four at once? Could they alternate the front up while the back go down? Maybe they're mostly propelling themselves just with their fore flippers, and then their hind flippers would have been mostly for stabilization, but I don't know. They're much more well developed than those of the mosasaur. Kind of imagine that these would have had to be for propulsion too. They don't look like they would have been just rudders, but again, I don't know. I don't work on these critters. I'm a dinosaur guy, so my hunches aren't really worth very much. But very, very cool to see. And note this is the original bone too. It is pretty neat. You can see that especially in the ribs. Those must have been such a pain to put back together. Look how scraggly they are. I know when I've dug up trach skeletons in the Hell Creek, when you get ribs like that, Oh man. You could see like so much of this material is original too. There's only a few bits there that are kind of nice and clean and straight. You can tell they're reconstructed. It must have been such a pain to dig up those ribs. I wonder if it was like all mixed together like pickup sticks, like a lot of these things get. Anyway, very, very cool. And then right up here, we've got a mammoth. I should read the label. I don't know if this is an imperial mammoth or a Columbian mammoth or what, but let's read about it. Ooh, Mammoth Imperator. Imperial mammoth. Very cool. In life, this mammoth stood about 13 feet high at the shoulder. It's about the same height at the hips as like a T-Rex, which we're going to see in just a second. Yeah. The tusks of this specimen have been reconstructed. One of the originals was missing and the other badly broken and in a poor state of preservation. Careful measurements were taken of the remaining tusk so that the length and shape of the replica is accurate. And that is extraordinary. I mean, look how long these are. Just amazing. And so those are homologous to, I think, shoot, is it the incisors or the canines? I forget. I think it's the incisors. So they're homologous to these teeth right here on you. Pretty cool. It's embarrassing. I feel like I should know if they're the incisors or the canines. Again, I'm not a mammal person. But yeah. Very cool. So much larger than any like modern elephant's tusks. So the label says the skull also had a rather large depression on the right side of the forehead. This is evidently the result of an injury acquired when the animal was young. It may well represent a wound received in a fight with another mammoth. This specimen was collected from the Pleistocene drift on the O.C. Pianist farm, 6 miles north of Mina, South Dakota. Very cool. Mina or Mina, I don't know. Pretty neat. Pretty neat. Very cool. And they are upper lateral incisors. Thank you, Lenina. I appreciate that. Yeah. Yeah. Very cool. And Miyar Osnabal. Hey, welcome to Paleontologizing. I don't think I've seen you here before. Good to have you. Yeah. Imagine the neck strength to hold the weight of those tusks. Yes, Zico, absolutely. And I kind of wish we had a skeleton that I could show you, but they've got these, like the withers, the kind of the, you know, raised part in between the shoulders is really, really tall on mammoths like this. Yeah, they've got these really long, so their spinal column as it goes through their shoulders, the neural spines, or what you might call the spinous processes, I guess, on a human skeleton. They're really, really tall for attachment points for all these big muscles and tendons to hold up that big, heavy head. It's pretty cool stuff. And then, let me show you this right here. Very, very cool. So this is a Tyrannosaurus skull, and obviously you're looking at it. This is a ventral view, so you're looking up at the roof of its mouth right now. You can see those big maxillary teeth. Super cool. The sign says this cranium of a Tyrannosaurus was found in Butte County, South Dakota, as part of an approximately 50% complete skeleton. Cool. At the time of its discovery in 1981, it was only the 6th specimen of T-Rex with an associated skull known in the entire world. Now there's probably about 40 or so. So this is the palatal bottom side, showing the distortion of this specimen. The distortion this specimen endured while it was still underground. Tyrannosaurus rex was the dominant predator in this region during the late Cretaceous period. The specimen was excavated from the Hell Creek Formation. Specimen number is SDSM, South Dakota School of Mines, 12047. Donated by the Floden family. Good for them. Holy cow. That you would have a private landowner who would donate a T-Rex I wish that sort of thing were common today. Before people thought that dinosaurs meant big money, you know? Belongs in a museum, and so we're super glad to see this here. This is really, really cool. Very neat. Oh, and there is a diagram showing the estimated completeness. So yeah, they've got skull, they've got lower jaw, we've got some ribs and some hips, and then the distal end of the tail. Very cool. Very, very cool. Yeah. Yeah. Really neat. And you get similar distortion on your Acrocanthosaurus tattoo. Is that right, Lenina? Very cool. But yeah, see how it's kind of squashed? Yeah, this is very common. So, this is clearly preserved. Yeah, look how squashed it is, like that. We get squashing like that occurs when there's a bunch of rock overlying it, especially if it's kind of, I don't know. This isn't like perfect squash flat laterally. It's not perfect squash flat ventrally. It must have been kind of like at an angle when it was buried. Really cool. Really cool. Pretty extraordinary. I doubt this will be the last genuine Tyrannosaurus skull that we see on this road trip, but I was not expecting to see this today. So that is, what a nice surprise. Very, very cool. Just extraordinary. Super neat. Alright, and with that, I think it might be about time for us to wrap this up. I've had a fantastic time here with all of you today. Hope you've had a great time too. Well, let's go ahead and see whom we can raid right now. And, yeah. And you're right, it is not every day you get to see a genuine T-Rex skull. Exactly, Triceratops, yeah. Or a genuine Triceratops skull, although they are a lot more common. Yeah, very cool. Yeah, let's see, who else is on Twitch right now? I will be streaming tomorrow morning, again, very early, I think. Gonna do a stream from Dinosaur Park in Rapid City. So you can tune in then, and it will be early, like, because I think I've got to go drive like 7 or 8 hours after that. So I'm going to try and do an early morning stream. But yeah. And let's see. Oh, and okay, I know what we're going to do. Did that work? And hang on a second, everybody. We're going to go check out some other scientists. And but I'm not sure if that command actually worked. And Clockwork Ninja, thank you for the 2 months. Really appreciate that. Holy cow.
If the situation called for still more protection, he simply grew spears which projected from his body armor.
Science streams. Oh, you're counting down. Shoot, I don't have any indication of that here. But thank you everybody for another wonderful stream. I hope to see you tomorrow. We're going to have many more of these this summer. And later on, even digging some dinosaurs live on Twitch, provided our equipment all works properly. So, yeah. And the command worked. Thank you, Lenina. Yeah. What are we at now for, because I can't see the countdown at all. Shoot. Thank you, Lenina, for being here. And I will drive safe. Thank you, Carlos. And Triceratops. Yeah. Almost there? All right, everybody. I'll see you later. Thanks for being here. Let's go check out Science Streams. Oh, 10-ish seconds. Okay, cool. Shoot, everybody. You all have a wonderful rest of your day. Stay curious. Remember to ask questions. And let's go hang out with Balint and Lita over at Science Streams.